Hey, it's Joe here, and I'm with Techie Bliss. Today, I'm going to talk to you about an amplifier project I've been working on. Now, this all began a few years ago when my grandmother gave me an old telephone. This was a real old telephone. It was back when they had party lines. And of course, it's not for anything useful other than just to look at. But my grandfather, many decades ago, had taken an old tube radio and placed it inside of it. So it would have some functionality. You put dials and whatnot on the sides of it so you could tune it and adjust the volume. Since then, it actually stopped working. And my grandmother gave it to me to see if I can get it to work. And I eventually did. I had to do some research in tubes. I have an electronics background, but tubes were a very elusive creature. I didn't really know much about them because tubes have, for the most part, been largely replaced by transistors and other semiconductors. So I figured this would be a good way for me to learn about something that I really don't know much about. One of the few places that you still see tubes used today are amplifiers, particularly bass and guitar amplifiers. And the main reason for this is that tubes have a unique property where once they are overdriven past their point for bias, they distort. And this is the behavior that you see very common in heavy metal bands and whatnot with distorted guitar. In fact, modern semiconductor-based guitar amplifiers use special signals processors to mimic the sound that occurs naturally with tube-based guitar amplifiers. And I figured, what better way to really learn tubes than to build something using tubes? So I decided, I like to play guitar. Not real good at it, but I do like to play. And I figured, what the heck? How about I try to build a guitar amplifier? Of course, me being me, I can't just build a standard looking guitar amplifier in a standard cabinet. I figured I'm going to do something really different. So this is what we've got. And one of the unique things about this opposed to a regular guitar amplifier is that I have these gauges here. These gauges do have a functionality. They're not necessary, but they do give a unique look to it. So one of the first things I noticed when messing with tubes is they run a very high voltage. Typically when you're messing with semiconductors, you're typically in 12 volts, 5 volts, things like that. With this, the bus here is in the 300 volts. So here we have the line voltage, of course. This is typically what you would see here. I'm in North America, so 120 volts is pretty typical. And here we also have the bus voltage. I'll go ahead and turn it back on. And you can see here the bus voltage is over 300 volts. Also here you can see the current. Since we're running at that really high voltage, our current's going to be in the milliamps. I also have gain, and the way this thing's set up is that there's 3 amplifier stages. And this is necessary because tubes don't typically have very high gain. So you have to run through multiple stages of amplification. So the gain regulates the gain going into the preamp. From here, we can do equalization. We have bass, middle, and treble. And then finally, we have the volume. The volume is the level going into your power amplification stage. Power amplifiers are the really big tubes that you see here. If I ever decided to feed the output of this into a soundboard, if I ever wanted to record something, I wouldn't be the one playing it, but if somebody were to take this and play, where after it goes to the preamp stages and so on, it can go straight into a soundboard, so you can still get that unique breakup sound and unique distortion. With amplification circuits, it's normally desirable to try to raise the signal level without distorting it in any way possible. That's one of the big goals of a designer, is to try to make an amplifier that can amplify as purely as possible without distorting or changing the signal in any other way other than just raising the signal level. But with musical instrument amplifiers, they're unique in the sense that you may want to distort. You may want to have those irregularities as they can provide a unique sound, just as a guitar can be different or other instruments can be different in the way that they sound based on their physical construction. The amplifier itself can be made to have an exact sound based on their construction. And in fact, tubes are so incredibly unique that depending on the type of tube used can dramatically change the way that the sound is heard. So this is unique in the sense of we want to create distortion, and that's actually how we get those unique sounds based on who our favorite band is and how their guitar riffs sound that unique way, because we've all seen cover bands and all that, and one of the reasons why cover bands sometimes don't have that exact sounds because they don't have the same amplification. Another unique attribute to tubes is that they work off of a principle called thermionic emissions. Now, every time we hear the word therm or thermal, we think heat. And that's exactly what's happening. Inside are these little heating elements that we see as glowing red because they're getting hot, and that heat allows them to work properly. But without that, they don't work. And in fact, that's why these tubes require time to warm up before they start working. So inside you can actually see these heating elements. That's why tubes glow red. And that's one of the reasons why semiconductors have largely replaced tubes, is because tubes are not very efficient. In fact, you can feel the heat coming off of these tubes. Another reason why tubes have been largely replaced by semiconductors is that they tend to wear out, and they have a relatively short lifespan, just like a light bulb, as compared to a semiconductor such as a transistor. So after starting the project, I realized that to get the full experience of working with tubes, I want to build it like they would 50 or 60 years ago. I also needed to do a wiring method called point-to-point. What you'll also notice on amplifiers, now this one is a little unique, but it's still very similar. This row right here is pretty much the same as you would see on a typical tube-based guitar amplifier. One of the things that you'll see is a standby circuit. And the reasoning for this is because, as we said before, that the heaters to heat up, this can take several seconds. And if you're about to perform, you don't necessarily want to wait that time. So they have the standby circuit so you can immediately turn it on. If I were to turn this off with the power going to the heaters, and once it cools down, you'll see the time it takes before the rectifier turns on and everything else comes on before you could actually use it. The approximate power is about 20 watts. I got a 10-inch speaker. I've got my horn over here since the cabinet's fully enclosed. Speakers on the bottom, and I got my speaker horn on the side here. For circuit protection, I got a 1 amp fuse. It's always very important anytime you have a project that you're running off of the AC voltage off of an outlet, that you always fuse it. You always want some circuit protection. I hope that you got something out of this video and maybe even inspire you to work on your own tube-based project. It's Joe here, and check out my other Techie Bliss videos.